This is a tutorial on how to use the t-test for paired samples in Excel with its data analysis toolpak. Here is our sample problem. A civil engineer wants to determine whether a new additive improves the workability of concrete measured by slump height in millimeters. She prepares 8 concrete mixes, testing each one before and after adding the new additive. So we have here the different data of this lump. So before the additive and after the additive. At the 0.05 significance level, can we conclude that the additive increases the mean slump? So this is a t-test because we do not have the population standard deviation or the population variance. And this is a paired sample because we have here a single sample but it has a data before and after or initial and final. So it is paired. So that is our clue for a t-test paired sample. So before we go with the t-test, let's write first the data. So we have here the 8 total samples, which is 8. Then we have the level of significance, which is 0.05. So that is also equal to that is also equal to 5%. So before we go to the data analysis tools, we will rewrite this data, separate it in 2 columns. So the slump after the additive and slump before the additive. Before that, so we need to write the HO and H1, which is the null hypothesis and the alternative hypothesis respectively. So for the null hypothesis, so there is no significant difference, or the slump, the mean slump of the concrete before the additive is equal to the slump after the additive. So there is no difference, so they are equal. For the alternative, so the question is, at the 0.05 significance level, can we conclude that the additive increases the mean slump? So we want to know if the additive increases the mean slump. So that is a directional alternative. So we will use the mean slump after the additive because we want to know if it increases the mean slump. The mean slump after the additive increases, so that is greater than the mean slump before the additive. So this is a one-tailed test. Specifically a right-tailed test because it is looking for a if the additive increases or increases the mean slump of the concrete. So after we write the hypothesis, we will copy the data in a separate column. So we will use this. So I will copy first the data after the additive. So that will be here. Then for the second column, so that will be before the additive. So now we will go to the data tab, then data analysis. So this is a paired sample, so we will choose the t-test for paired 2 samples and click on OK. So for the variable 1 range, we will highlight the data after because we want to know if the additive increases the mean slump after adding it. So our variable 1 should be the after or the final data. So I will just highlight the data And for the variable 2 range, that will be the before. For the hypothesized mean difference, so we will input here 0 because we are checking if the mean slump after the additive is greater than the mean slump before the additive, meaning is it greater than 0. So that is 0. For the labels, I will not check this because I did not highlight the labels, even though I have inputted here the labels, but when I highlighted the data for the variable 1 range, we did not include the labels, so we will not check that. For the alpha, so that is the level of significance, which is equal to 0.05, so that is okay. For the output range, so we will select any blank cell, then click on OK. So here is the result. So for the mean of the variable 1, that is 70.375. For the variable 2, that is 66.75. So here is the variance. So it was automatically computed. Then we have a total of 8 samples or observations. So we have 8 mixed. Then for the Pearson correlation, so the correlation indicates whether the two variables, the before and after, is related. Is it positive or negative? So this is nearly equal to 1, meaning as the one variable increases, the second variable also increases. Then the hypothesized mean is 0. For the degrees of freedom, so this is a one sample but a paired test, so that is 8 minus 1, which is equal to 7. So the computed t stat is equal to 9.6667. So we will choose the critical value for one-tailed test because this is a one-tailed test, so this is our critical value. So comparing it or checking it with the critical region, so this is our critical region. So it is a one-tailed, specifically a right-tailed test. So here is our critical value, which is equal to 1.89. Then the t-value is positive 9.6 or approximately 9.7. So this is our t-stat, meaning the t-stat or the t-value falls in the critical region. So our decision is we reject HO. So for the conclusion, because we rejected the HO, we can conclude that at the 0.05 level of significance, there is sufficient evidence to conclude that the additive increases the mean slump height, which improves or improving the workability of the concrete. So that is our conclusion. Or we can also use the alpha. So we will check its p-value. So for one tail, because it's a one tail, so the p-value for one tail is 1.33 times 10. So e, that is times 10 raised to negative 0.5, meaning this is less than the alpha na 0.05. So if the p-value is less than the alpha, we reject HO, which is the same with our decision when we have used the t-stat and the t-critical. So this is how we use the Excel if we want to perform t-test for paired samples.